Hello everyone, I am Adıgüzeloğlu. Today I'm going to introduce you EEE 415 Analog CMOS Integrated Circuit OPAMP design project. At the beginning of the project we are given 4 different topologies, and from these topologies I have chosen the fourth one. Here you can see the design requirements of OPAMP. And this is the schematic design. Here you can see V over L ratios of all transistors, and in this green box there is a resistor and capacitor, and these are used for stabilization purposes. Test results: maximum supply current is 1.45 milliampere, which is less than 10 milliampere, so it satisfies the requirement. Here you can see output voltage ranges between 2.32 volt to 2.59, while the input range is between 0.7 to 3 volts. Circuit is constructed to test the common mode rejection ratio, and the common mode rejection ratio is 62.84 dBs, and the power supply rejection ratio is 59 dBs. Another circuit is implemented to test the phase margin, and the phase margin here you can see is 55.2 degrees, which is between 50 and 60 degrees. The second part of the project we are supposed to make a quad OPAMP, and in order to make this part I separate the bias circuit and amplifier circuit from each other. After doing that, here you can see the layout design of the amplifier part, and here MMOSs and PMOSs are vertically symmetrical to each other, and in this process I made first DRC run and LVS run. I made DRC run in order to make sure that there is no connection error, and here you can see I made also LVS run in order to make sure there is no net mismatch errors, and here you can see it says that schematic and layout matches, so there is no problem with this run. After completing the amplifier part, I go to the bias circuit, and same procedure also applied for bias circuit. Here you can see the bias circuit schematic, and this is the bias circuit layout, and as I said, same procedure also applied for bias layout. I made first a DRC run and also made LVC run. Here you can see the result of the LVC run. After completing the amplifier and bias circuits, I made symbols of them. Here you can see the bias circuit symbol, and this is the OPAMP circuit symbol, and by combining all of them I made the schematic of quad OPAMP. After completing this part, I pass on to the layout design of quad OPAMP. Here you can see the bias layout. These are the OPAMP's layout, and these are the inside of this quad OPAMP layout. This is the VDD rail, this is VBIAS1 rail, this is VBIAS2 rail, this is the ground rail, and as I do in all parts, I also make in this part a DRC check and also LVS check, and here you can see the result of the LVS check. There is no problem with LVS check. After completing this part, I made a QRC run in order to get the AV extracted. Here you can see the result of the circuit. The phase margin is 55.3, which is between 50 and 60 degrees, so there is no problem with stabilization. And this is the noise analysis. Here you can see while the frequency increases, noise decreases, and while the frequency decreases, noises increases. At the last part, here you can see integrated noise summary. These are the specific part of the circuit, and these are noise contribution of that parts, and here you can see the total summarized noise. Thank you for listening.